So now we see the relations between the properties of waves or electromagnetic radiations. So for any wave there is already we know the properties wavelength. So what are the main properties of wave? Wavelength lambda. Frequency that is nu. Wave number that is nu bar. And we know the velocity of wave is equal to the speed of light. That is c is equal to 3 into 10 power 8 meter per second, or c equal 3.0 into 10 power 10 centimeter per second. There is a relation between this lambda, nu and nu bar. So these are mainly useful in the comparison of these properties and in the calculations. See the wavelength, the relation is nu is equal to c by lambda, relation between nu and lambda. Next, nu bar is equal to always 1 by lambda. Nu bar is equal to always 1 by lambda. You see this equal to the speed of light. So substitute this 1 by lambda in this. Okay, means with the help of these two we can write nu is equal to c by lambda, means in the place of by lambda 1 by lambda you can write the nu bar. So nu is equal to c into nu bar. So these are the main three relations between these properties mainly used in the calculations. Now we can compare their relation. Comparing relation means the frequency is inversely proportional to its wavelength, whereas here frequency directly proportional to its wave number, and the wave number is inversely proportional to its wavelength. Means with the help of the three equations we can write nu is proportional to lambda. So actually with the help of these relations only we got this equation. Thus we are taking an opposite. To get other formulas we are writing the reversing. Nu is inversely proportional to lambda. Nu is directly proportional to nu bar. Nu bar is directly proportional to lambda. In some problems there is two comparisons will be given. So with right here we can write nu 1 by nu 2 is equal to, as it is a reversible reaction, nothing but sorry, as it is a inversely proportional lambda 2 by lambda 1. Here nu 1 by nu 2 is equal to same nu 1 bar by nu 2 bar, as it is directly proportional. So nu 1 bar by nu 2 bar equal to, here inversely proportional means lambda 2 bar, sorry, lambda 2 by lambda 1. Okay. So these are the relations between the properties of waves. Now we do some calculation based on these formulas. Okay. Okay, see the related problem. So the Vivid Bharati station, so of All India Radio, it's a radio station, the center of Delhi. Okay, so worked on a frequency mode. What's the frequency mode? 1.368 kilohertz. When the frequency is given as 1.368 kilohertz, and we need to calculate the wavelength of that electromagnetic radiation emitted by it. Okay, on this frequency it is worked and releases some radiations of having this much of frequency. So we need to find its wavelength, means it is given in terms of frequency. We need to convert that frequency into wavelength, and here it is also asked that that part of wavelength or the frequency belongs to which region of in the electromagnetic spectrum. Okay, so here the value given, the frequency is given as 1.368 kilohertz. So we always do the calculation only in hertz. We not at all calculate the problems with the help of kilohertz. We must convert the kilohertz into hertz. Okay, so next we need to find out what? We need to find the wavelength lambda. So what is the relation between these two? So what is the relation? Nu is equal to C by lambda. So we need to find the lambda. So lambda is equal to C by nu. C, we know the speed of light. This we are taking in terms of meters here. What is the frequency? Say 1368. That is hertz. And here finally we get 219.3 meters of wavelength. Okay. Okay, let's take it. Let's see the next one. So the wavelength range of visible spectrum, nothing but a visible region, is from violet to red. We know that Vidya. So violet to red. Here the wavelength of the violet color is given 700 nanometer, whereas red color wavelength is given 750 nanometers. Just we need to express them in their frequencies. Simply the wavelengths are given, we need to convert them into their frequencies. First we see about violet color. For violet, what is the frequency? Sorry, what is the wavelength? 400 nanometers. We never do the problem in nanometers. Always we do the problems in meters or centimeters only. So it is equal to 400 into 10 power minus 9 meters. Nano indicates minus 9 here. We need to find what is its frequency. So we know that U is equal to C by lambda, that is what is C? 3 into 10 power 8 meter per second. What is the lambda? 9. So this becomes 10 square. Points. Hertz. Okay, this is the frequency of that violet color. Similarly, we do the frequency of red color. For red color, it is given that lambda equal to 750 nanometer. Minus 9 meters. We need to again find out the frequency. nu is equal to C by lambda. It's meters per second. So here 3 by 75 means we get 0. Approximately 0.4 16, that is 4 into 10 power 14 hertz. Means the range of the visual spectrum is from 7.5 to 10 power 4 hertz to, it's violet, it indicates violet, to 4 into 10 power 14 hertz. 7 in approximately 7.5 into 10 power 14 hertz to 4 into 10 power 14 hertz. Means frequencies we know that always decreases. The frequency decreases from 7.5 10 power 14 to 4 into 10 power 14 hertz. Okay. Okay, see the next. So calculate the wave number and frequency of yellow color radiation. So having the wavelength 58 angstroms. Here wavelength is given. We need to find the wave number and frequency simply using their relation. So we know that first we calculate the wave number. Okay. First we do the calculation of wave number. Okay. Here the wave number, the lambda is given as 58 angstroms. So we never do the problem in terms of angstroms. So convert it into meters. 10 meters. So find the nu bar. So what is the relation nu bar to lambda? We know that nu bar is equal to 1 by lambda. So that is 1 by that is 1 by 58 into, so 1 by 58 means 8, as it is a wavelength that is taken in meter, become meter inverse. So this is a wave number for this wavelength. Now find the frequency. Now we find the frequency. You know the relation. Here lambda is given same 5800. Find the new value. We know these two relations. That is nu is equal to C by lambda. C taken as a, so it is in terms of meter. So the speed must be taken in terms of meters. That is by 58 gives that so as its frequency, that is in hertz. It's meters per second. Meters is cancelled, becomes only second inverse. Here it is meters per second. Here it is in meters. Meters gets cancelled, means second inverse, which is equal to hertz. Okay. We always know the hertz is exactly equal to the second inverse numerically. Okay. Okay, next see the last one. So calculate the wavelength of an ultraviolet wave. An ultraviolet wave, if its frequency is 12 to 10 power 16 cycles per second, means nothing but hertz or the second inverse. Paint here. The frequency is given, the nu is equal to 12 into 10 power 16 cycle per second, nothing but hertz, no change in it. We need to find the wavelength. Find the wavelength. And we know the relation. Nu is equal to C by lambda. Okay, C we take as 10 power 8 meter per second. Here what is this? 12 into 10 power 16 hertz, or we can write second inverse. Get cancelled. This 1 by 4, 10 power 8. 16, and it becomes 1 by 4 and 10 power 2 5, and then for minus 16, that is 10 power minus 8. Here we are calculating lambda, so lambda becomes C by nu. Okay. Lambda becomes C by nu. Let's see, this is nu. Okay. So now this is in meters. Okay. So this is the wavelength.